name is Payton. I'm DDL Packaging Sales Engineer here with Scott Levy, Senior Packaging Engineer as well.
Morning, Alison.
Welcome back. Today we're wrapping up our two-part series to talk about common mistakes we encounter regarding sterile packaging that can lead to failures in your validation. We hope that you'll be able to take some valuable information away from this session and apply it to your own work. Scott, at DDL we do a lot of testing. We see a lot of successful validations, but we do sometimes encounter the dreaded failures.
Failures, don't say the word.
Starting with the sterile barrier system, what are some considerations our customers should take when picking out materials?
Absolutely. So, I mean, from my perspective, it all boils down to the product itself. What type of product you have. Mass, geometry are probably two of the key attributes that you need to look at in choosing the right package to, encapsulate it. For example, if I've got a multi-material product that's got a lot of sharp edges or points, etc. on it, then I'm not going to want to put this into a pouch.
Sure. Right?
It should go into a tray. Or if I'm dealing with a product that's got a lot of mass, again, I really don't want to put that inside of a pouch just for that reason. I mean, a mass inside of a pouch is like a projectile versus putting it into a tray to try to encapsulate it a little bit further.
Sure.
So understanding the product you have, the mass, the geometry, etc., are key and very important factors in choosing the type of package you're going to use, whether it's a pouch or it's going to be a tray.
Sure.
Ironically enough, I see pouches are pretty much readily easy available, right? You can get these from the suppliers relatively pretty quick versus a tray. And when you're dealing with trays, you need to deal with the cavity. I mean, there's a lot of things that go along with a tray package itself, the sealer, etc. I mean, you name it. So a lot of people will try to put a heavier product inside of a pouch and kind of give it, that things are going to work properly.
Right. I've seen that too, where you have something super heavy and that's going to be shaken around and potentially breaching some of those seals. So doing a little bit more work up front with considering a tray is definitely going to make more of a difference.
Absolutely. We see a lot of great package configurations come through, and we see a lot of not so great configurations come through.
Sure. And
it's all about speed, right? Most companies, it's all about speed to market, speed to get testing done, speed to get the materials, etc. But understanding that up front is probably paramount.
To save more time in the end.
Absolutely.
Sure.
Absolutely.
Do you see any common mistakes in the process validation?
Absolutely. Process validation to me is key and critical. I look at process validation as building a brand new house, right? Your foundation needs to be poured straight, it needs to be poured level, etc. Otherwise you can't build off of it. So package validation up here needs to build off that process validation. Now in saying that, I see a lot of issues with oversealing, undersealing. I see a lot of issues with not understanding the actual processing parameters, your low, your nominal, and your high, basically your processing window. I also see a lot of issues with choosing what strength level to use as on your low end or your high end.
That's a big one, yeah.
I mean, every day I run into the same issue. Well, the strength values are all over the place, right? And then stepping back, trying to understand what they did further in the process validation is key. Or we end up with tray packages, or we end up with pouches that are oversealed. And it's an extremely common mistake. So stepping through that process validation is key and critical. It is. Otherwise, you cannot have a successful package validation because more questions will get answered if a failure arises.
You go back to that.
You
process,
start essentially all over.
Sure.
But understanding what that low end is pretty critical as what that high end is. And that processing window is key and critical because you're sealing every day, right?
Right.
So if you're at your nominal every day and you start seeing samples that are oversealed or undersealed, well, there's obviously an issue, right? The sealer is not staying within the specific tolerances that you put together. And then understanding what those strength levels are as well. If a package, whether it's a tray or a pouch, if it's gone through, I'm going to say, the correct process validation, where somebody's really done their due diligence, the consistency of those seals is absolutely there.
Sure.
The other thing I see is the seal width, right?
Yeah.
Especially for trays. If there's too much, the platen comes down, it's pushing on it too hard, comes back off, the Tyvek releases a little bit from the tray itself, and we have problems, right? Because now your seal width is thinner. Maybe it's a 3/8 seal, whatever it is. Now it's way less than that. So understanding that seal width up front is pretty critical as well.
Sure. That's a good consideration too. I don't hear a lot of that, but I'm definitely going to mention that to some of my clients too.
Well, currently we're working with a project, and I'm working with the client, and I'm trying to back them up, right? And trying to figure out what could have potentially caused it. Now, granted, it's a heavier product inside, but were those samples inspected? And
Sure.
there's another facet of process validation, is truly inspecting these seals and making sure that everything is, I'm going to say copacetic, everything is in good shape.
Sure.
And then, for package validation work, after it's gotten done with process validation and it's gone through ETO or GAM or whatever it's gone through, the inspection of those samples is critical to make sure that sterilization hasn't caused any adverse effects as well.
Yeah.
Typically, when samples arrive at DDL, right, we're expecting them to be pristine, right, ready to go to the market. Samples.
Sure. Yep.
And we see a lot of samples in that scenario where the seals are popped, or the seal width is at 1/8 of an inch. I mean, there's a lot of facets that go along, but this all leads back to process validation and understanding what you're going to get out time in, time out. The criticality in process validation is overall consistency.
Got to have a good baseline, a good foundation. Like
Absolutely. Otherwise, you can't build off it.
Sure. So, all right, now we're feeling a little more confident with our sterile barrier system and our process validation. What are some common mistakes we see when clients are putting together their whole shipping configuration?
The shipping configuration, I think, is paramount, right? Let's say I'm dealing with a heavy product, it's in a tray, and the overall orientation, right? I think that's key. Let's say you're side loading these and you got a heavy product. Well, you're primarily going to run into issues because that's the bottom orientation and your sample's orientated on the side or on its end, right? You ideally want these on the bottom orientation. So we ran into quite a number of issues where we've had to go back and work with the customer itself and say, have you tried this? Based upon X, Y, Z type of failure modes we're saying, I think you're going to be better suited. Does that solve 100% of the issue? It solves the majority, right? Sure. Because it's the bottom orientation. The other aspects I see all the time are abrasion issues, abrasion failures, right? When you put, the reason why I'm bringing that up is if you put bare packaging and corrugated is nothing more than sandpaper, right? It's paper, right? If you've got too many packages inside that shipper and they're abrading on the corrugated, right? What's going to end up happening? You're going to end up with an abrasion hole.
Sure.
Whether it's a good size hole or a very small hole. And in my experience, it's usually a very small hole. Second aspect I see a lot is a lot of these packages are in there. They may not get abrasion hole from the corrugated, but they will get abrasion issues directly from touching one another. Especially, again, remember we talked about the type of packaging, the type of product, right? Certain products lend themselves better to specific type packages. So again, if you have a multi-port product and you're putting them in a pouch and you're putting 5 or 10 of these pouches in a corrugated shipper that has no shelf boxes, right? You're potentially looking for problems, right?
Sure.
The other aspect I see is the folding of the pouches, right?
Yep.
Folding of pouches inside, whether it is just a corrugated box or not, you're breaking the fibers. You're breaking the fibers of the Tyvek, or bending the fibers, I should say, as well as bending, whether it's mylar, or mylar, nylon, etc. You're running into issues where abrasion of the product. Here's a prime example. So we're dealing with a backer card. Okay, a backer card in a pouch. Pouch is folded. The backer card is moving back and forth inside the package, creating a hole.
Yeah. A
very small hole, but a hole nonetheless.
It still matters.
Absolutely. It's like the biggest consideration I see is if I could put sterile packages every single time into shelf boxes, I would. It just protects them so much more. So I'm a firm believer of shelf boxes, maximizing my shipping configuration with those shelf boxes and the sterile barrier. That just lends itself to a continuity situation where it's going to give you the best chance of passing shipping validation. The other aspect I see with shipping validations is compression.
Yes.
Right? So typically for D4169, DC13, the standard height utilized is 108 inches, right? And based upon the 108 inches, you've got a pretty good size compressive load that needs to come down. And a lot of people get very uptight with not meeting that specific calculated load.
Right, yes.
Run into this all the time.
Huge question for my clients as well.
It's not truly a failure, okay?
Yeah.
The standard itself is a conditioning test. All that compression testing is telling you is how much compressive load that box can handle. Whether it fails to meet 2,000 pounds based upon that calculation really means absolutely nothing in my opinion. If your box is reaching 1,500 pounds, is that good? Well, from a package engineering standpoint, I think it's fantastic.
Sure.
Because if you have a failure in the field, right, you know something 1,500 pounds or greater was on top of that box.
Yeah.
That's what I'm learning from compression testing. Back to distribution sim. Oh, let me finish one more question because I get this question a lot too.
Sure.
So, Scott, I want to use 54 inches.
Yep.
Right? Instead of 108 for the stack height. You can use 54 inches if you're setting your samples in an LTL scenario. Okay?
Sure.
If it's not LTL, you shouldn't be using it per how the standard is written. It's not as obvious within the standard. You really have to read and understand what they're specifically stating there. But 54 inches is meant for LTL shipment only. And why do people want to use 54 inches? Because your overall compressive load comes down, right? You're kind of hedging your bets that you're going to pass that compression or the perceived perception, right? Another big aspect they see in distribution and failures we're talking about, obviously I want everything in the shelf box, right?
Yeah, that would be the most ideal.
That's ideal. Is concentrated impacts. Okay, that's Schedule J of the D4169.
Yep.
In an ideal world, I would like every medical device manufacturer to have a box, a single wall box rated at 44 ECT or 275 pound burst strength. Those are the two magical numbers.
Yeah.
If you do that, you can exclude Schedule J. Now, if I've got a 32 ECT box, that's pretty much standard in the industry because it's relatively very cheap.
Sure.
Okay. Now, if I've got a box of 25 pouches that are not in a shelf box, and I run concentrated impact on the faces of the box, I know that that dart is going to penetrate those boxes. Is it going to hit the packaging? Absolutely it is. So, being proactive and understanding what Schedule J is truly meant for, and then having a box to meet the requirements to exclude it, it's a little bit more money, but it's going to save you a lot of heartache and headache down the road.
Right. That makes a lot of sense. And I mean, even just seeing an Amazon package come to me, and you can see there's just a huge hole in the side of it, and you can see the product inside.
Well,
so if we can avoid that, let's,
Absolutely. I mean, when I get a box from Amazon like that, do I want the product anymore?
Exactly. Yeah.
And I'm like, as a packaging engineer, I'm going, odds are it's probably okay.
Yeah.
Odds are, but it makes me pause. Just like every other person in the world pauses when they see a hole in their box. Or a TV box that has a hole in it. I'm like, ooh, I don't want this.
What does the inside look like?
I mean, I'm as freakish about this as possible. Even when I'm at Target and something's dented, I'll pull it out and grab one.
The next one, I'm the same way, yeah.
I mean, why have any stress to a box when I don't need to have stress in that box that could potentially telegraph to that product?
Right.
I mean, that's kind of common sense. I think that's the way a lot of us view packaging, holes in boxes, etc. But for sterile packages, you want to try to avoid putting any undue necessary stresses on that box than you truly have to. That's the key and critical element.
Sure. That makes sense. When talking about bubble leak, I get a lot of questions about perceived failures in the Tyvek. Can you tell me a little bit more about that? Are you hearing that question as well?
I've dealt with it in the past.
Sure.
All right, so when Tyvek is folded, right? You have a tortuous path, right? The fibers will open up.
Sure.
All right, letting air escape out. Is that a failure? No. So usually at DDL, when we see something like that it's coming through the Tyvek, then you've got to run a secondary test on it.
Sure.
I'm sure you've seen a lot of protocols say as well.
Absolutely support with dye leak.
Yes. If a perceived failure in the Tyvek is there, to execute dye penetration on that perceived area.
Yep.
And I'll say 99.9%, it's not a failure. All it is separation. There's an article out there, and I believe it was done by, he's passed away, Kurt Larson from Spartan Design Group that used to work for DuPont. that showed this. So there's an article out there that talks about this, a perception of failure in Tyvek.
Mm-hmm.
But that's only in Tyvek.
Sure. And that's good to use a secondary means to evaluate that.
Absolutely.
You know, if you see it, just to make sure that it's not or it is a true failure.
Almost, Tyvek's great material.
Yep.
Okay, it's great for puncture resistance, it's great for abrasion. Where we run into the problems the most are on the mylar, the poly, nylon, the film side is primarily we run into the issues, not so much on the Tyvek. But
Sure.
occasionally that will happen where, like I said, a tortuous path will open up a little bit. That doesn't necessarily mean that a micro can get through there.
Right.
It means the air is escaping in a steady stream.
That makes sense. So we talked a little about simulated distribution, and I know a lot of failures can occur from the dynamic effects of simulated distribution. But what about considerations with the sterile barrier system during aging, specifically accelerated aging?
Absolutely. I like to try to head this off before we even put samples into the aging chamber. Understanding the materials, right? Understand what those specific materials can handle for aging temperatures. That's A. That's pretty much key and critical. I'll tell you, I've been with DDL 29 years now, and when I first started, I had a customer send me a PET G tray and wanted to put it at 70C. I didn't know any better. Right? I put samples in on a Friday afternoon, and Monday I got back to go grab the samples out, and I had sludge. So, I mean, understanding what those materials can handle is key and critical, right?
Sure.
The materials will fail if you pick a temperature that is not a proponent to what it can actually handle.
Yes.
The other ones I see is underseal and overseal. Hands down, that's probably the biggest attribute of a failure mechanism that I see.
Okay.
The materials themselves, I don't see too much of an issue unless you pick the wrong temperature.
That temperature is really key.
Yep.
Any considerations with humidity now because of the latest revision?
Absolutely. So to be a little bit more environmentally proactive, originally they used adhesive-based tie layers, right? You have a multi-layer material and it's really an adhesive, right? And now they use water-based tie layers. And using water-based tie layers and the presence of that much moisture is going to delaminate. Okay? So in bubble leak testing, let's hop off of aging, we'll come back. Okay? Sure. In bubble leak testing, if you have a multi-layer material, I get this question a lot. Why do my materials delaminate after bubble leak? All right? Well, as you're injecting air and submerging a package underwater, the humidity level, you're going to get some droplets of water or a little bit of water inside the package. That's why it's a destructive test. Sure. Okay? Now, if you leave those samples sit, it has a water-based tie layer for 24 or 48 hours, magically the materials start to delaminate. Customer wants the samples back and says, what happened to my materials? Why are they delaminating? We have a big problem. And it's not. It's just the amount of absolute moisture that's inside that pouch that's causing those materials to break down.
Sure.
Okay, now back to aging.
Yeah.
Now, if I have a hydrolytic product, okay, am I gonna try to age that multi-layer material at the high humidity same time?
Yeah.
No. So remember, I think in our last video we talked about F1980, and if a material is hydrolytic, you need to use basically 50% RH.
Exactly. Yep.
Right?
Yep.
So if you were coming to me and say, Scott, I've got a hydrolytic product, but I have a multi-layer material, we'd be splitting this up. I would be counseling them to put dunnage product inside the packaging, for aging distribution. And then I would deal with the product side aging all by itself at the higher humidity. So we'd run the product that's hydrolytic at the higher temperature and humidity, and then run the accelerated aging portion at a less than or ambient RH scenario, so that we do not make a failure that's not going to be real world quality.
Sure, that makes sense. It's a good consideration. So now moving on to real-time aging. So a lot of our clients store real-time aging samples with us, but some of us choose to store them internally. Any benefits or disadvantages to either approach?
Depends, right? Almost everything in packaging depends, right?
All
right, so here's a prime example. Just had a customer call me last week. I don't know that specific individual, but I know the company very well. Frantic. Can't find their samples for real time. Okay? This happens a lot. So I take a look around, find the person I was working with back 5 years ago, and by God, we don't have the real-time samples. They were going to be aged internally. I mean, I've got documentation to say that, right?
Right.
You know, we're going to take care of the aging ourselves. That's a big bone of contention. We know that most engineers, maybe today it's, I don't know, 5 to 7 year shelf life for an engineer to stay at a specific company and jump on. Might be even less.
Sure.
Now, when a customer's wanting 5-year real-time aging or 10-year real-time aging, what are the odds that they're going to remain at that company? Right? So back to the customer that called, they were pretty frantic, and I felt for them because, well, they've got their accelerated aging data, everything's great, but they don't have the real-time samples.
Real-time support, right?
So I felt my heart went out there. For us to take the samples and put them on the shelf and document full traceability of the temperature, humidity, and us managing it, hands down, is the easiest and fastest. You know, there's, what commercial am I thinking of? Set it and forget it.
There you go, yeah.
Right?
Mm-hmm.
But it, honest to God, it is the truth, because we've got project managers that are tasked for these projects. This just happened about 3 weeks ago. Project manager contacts me and says, listen, I can't get a hold of XYZ.
Mm-hmm.
I'm like, okay, so I did a little bit of research. XYZ is no longer there. But I have multiple contacts at that specific company that I started firing emails out saying, listen, your real-time agent's coming due for XYZ product. And all of a sudden, about, I don't know, 3 days later, he pings me back. Thank God you have them because we can't find them.
We couldn't find them, sure.
So, you know, in situations like that, it's fantastic. Again, set it and forget it.
Mm-hmm.
So, I mean, for a lot of customers, that's pretty important, right? Full traceability. You know, the data that we're going to give them back, they're going to be able to stand on their own 2 feet with. It's solid data versus a lot of scenarios I give with clients, they've been sitting under my desk for 3 years.
Mm-hmm.
Well, great. Did you record the temperature and humidity? We're seeing this for all the time from the regulatory bodies. Show me the data for your real-time aging.
Sure.
And you can do that, don't get me wrong.
Mm-hmm.
You can definitely do that. You can record the temperature every day, the humidity every day, log it. But most customers, you know what? They're good at what they do. They
Mm-hmm.
design medical devices. They don't want to worry about this thing real-time aging.
Sure.
It just, in the grand scheme of things, it's I kind of say it's a no-brainer, to be honest with you.
Right.
If we're putting together a full package validation, let us store the real-time aging samples. You don't have to worry about it. You're good at what you do.
We
We're
know
good
where
at
they
what
are.
we
It's
do.
traceable. Yeah.
And it's fully traceable. And if you leave, I'm gonna be able to get a hold of someone, let them know that your real-time aging's due. Testing's done. Report's ready. I mean, it's just a very easy scenario.
Sure. That makes a lot of sense. And that real-time aging data, that's valuable. I mean, that's years and years of data. So losing that is a
It's
huge
critical.
risk. Right.
And ISO 11607 allows you to use accelerated aging and bring your product to market.
Yep.
Right? Without the real time, you're running into a huge problem. Because typically they will, when they come in for an audit, they want to see the data, right?
Mm-hmm.
It's not like you're submitting real-time data back to the FDA. That's not really typically how it works. How it typically works is you finish your real-time aging up, you get your data, you put it in your master document file. When the FDA comes in, now they're looking for it.
Mm-hmm.
So, I mean, it's like, you know, when you can stay out of risk's way, you want to stay out of
We want
risk's
to
way.
do that, right?
You know?
Exactly. That makes a lot of sense. If you have any questions or should need any assistance, please visit our website at ddltesting.com.